This time we're going to solve an equation that has logs on either side of the equation, and they're both logs to the base 2. Now, since they're both logs to the base 2, we can simply get rid of them. What we're really doing there is it's hidden, but we're really raising both of these to log to the base 2 of x squared minus 4 equals 2 log to the base 2 of 3x. And then we are cancelling out the log 2 and the 2, log 2 and the 2, and we're going to be left with x squared minus 4 equals 3x, the same as what we actually have over here. X squared minus 4 equals 3x. So we've gone from a logarithmic equation to a quadratic equation, an x squared, an x, and a number. And for solving quadratic equations, the easiest thing to do is to move everything to the left-hand side usually. So if we do that, if we bring the net 3x over, it becomes minus 3x minus 4 equals 0. Now this is a simple trinomial. Okay, you have to recognize these things yourself when they appear. So then you go back and you use what you know about simple trinomials. So there's a little bit of review on this, but really trinomials appear so often that there's something you always have to be looking out for and always have to know how to deal with. So to solve a simple trinomial, you get factors, and factors of x squared are x and x. Now you want factors of 4 that subtract to give 3. Okay, so 4 and 1 will subtract to give 3. The first sign in the quadratic equation is a minus, so put a minus in front of the bigger number in your answer, so minus there. And the last sign was also a minus. Now when the last sign is a minus, it tells you that you need two different signs in your factors. So we already have a minus, this becomes a plus. And then we go x minus 4 equals 0, and x plus 1 equals 0. So this gives you x equals 4. X equals 4 and x equals negative 1. So it looks like, I'm going to use dash line for these because there's still some work to do, but it looks like we have two answers, and possibilities are x equals negative 4 and x equals negative 1. But if you look back at this question, it did tell you to check for extraneous solutions, which is a hint that there's more work to do in this. And in fact, anytime you're dealing with a log equation, you should always check for extraneous solutions. So let's do that now. So this is now going to be the checking section. We'll do it down here. And the equation we want to check is the original equation. So log to the base 2 of x squared minus 4 equals log to the base 2 of 3x. So we're going to check with both. So let's say we start with x equals 4. Okay, then that gives you the log to the base 2 of 4 squared minus 4 equals log to the base 2 of 3 times 4. So that would be the log to the base 2. 4 squared is 16 minus 4 is 12 equals log to the base 2. 3 4s are 12. Doesn't seem to be any problems with that one, so that's good. X equals 4 is a solution. Now the other answer we had was x equals negative 1, so let's try that one now. X equals negative 1, and this is the thing that we check. That was the original problem. So if we check that, we get the log to the base 2 of negative 1 squared minus 4 equals log to the base 2 of 3 times negative 1. Well, that would be log to the base 2. Negative 1 squared is 1. 1 minus 4 is minus 3 equals log to the base 2. 3 times minus 1 is minus 3. So you've got the same thing on the left and on the right. But you cannot get the logs of negative numbers. Okay? You cannot get the logs. Get the log of negative numbers. and therefore x equals minus 1 is what gave rise to this. X equals minus 1 is not a solution. Okay? So everything may look alright, and both sides of the equation may end up the same, but you just simply can't get the log of the negative number, and so therefore this answer has to be thrown out. So the only solution to the original equation is x equals 4. Okay, thanks for watching.